Всім привіт! Вітаю на каналі Літкод Україна. Так, сьогодні з нами Єгор. Я
Так,
проведу для Єгора тренувальну співбесіду, або як їх ще часто називають, мок інтерв'ю. От, у нас буде одна задачка, medium, там є багато про що поговорити. От, співбесіда буде англійською, і якщо ви також проходите або проводите такі тренувальні співбесіди, я вам також рекомендую це робити англійською, бо це максимально наближено до реальних мов. So, Yehor, it's nice to have you
так,
with us today. How are you doing?
так, так, вітання всім. And hello, Nikita. Thank you for inviting to the interview. And
Sure.
I'm okay.
Yeah, that's actually good in considering the context. I mean,
Yeah.
usually people would ask you like, how's the weather or stuff like that. But obviously, with you coming from Ukraine, just being okay is already a good sign.
Yes,
Uh,
not hearing how the rockets are flying, so
yeah,
it's
yeah,
okay.
absolutely. All right, Igor. So sometimes we would have some like behavioral questions here, but today we'll skip straight to the problems. Is that okay?
Okay. Yep.
Sure. So for today's problem, I would like you to design a small class with just a couple of methods. That would be a leaderboard class. All right.
Okay.
So this class has three methods. First of all, you can add some score to the given player. So you get a player ID and a score, right? And that increments their score. For example, several people like are playing a board game or something. And one of the methods, when you call it, with given player ID and score, it increments the score. It is also possible to reset the score of a given player. That basically resets the score to 0. And finally, I would like to implement the method top, which takes in a parameter k and returns the sum of scores of top k players. I can probably paste a short description for you if you don't mind.
Oh, yeah, I don't mind.
One second. You
Oh,
want a
this
leaderboard
looks
class,
nice.
3 functions. Add score, increments the score by a given amount. Resets the score to 0. And top k returns the score sum of top k players, the sum of scores.
Okay. The most interesting function in this problem is top k, so it doesn't allow us to use only a hash map for this question, because if we would have only add score and reset functions, we would just use a simple hash map for this purposes. Yeah, but
Yeah, allow me to interrupt yourself briefly.
okay.
Technically, if we only had add score and reset, we could do nothing because there would be no function retrieving the information. You know, if every function returns void, you can do nothing and nobody will catch you red-handed. That is just
Okay.
yeah.
Yeah.
Have to design an interface. Your interface should return something at least at some point.
Yeah, at least retrieve some information, yeah,
Yes,
from the system.
yes, that's right. But yeah, using a hash map is a possibility here.
Okay. Another another way to doing this problem is to implement a top function in linear time. So we would retrieve all the information from the hash map and sort it by the top of k players. Yeah. So we have to
by the
find
score.
yeah, by the score to find top key players. And I set it incorrectly that it's a linear time. It's not a linear time. It's n log n. Yeah. So in
if
this,
if you sort the entire thing, then yes, it would take off n log n, where n is the number of players.
Yeah.
Yeah.
So it's one way of implementation of this problem, the top function, but it's not the optimal one.
Or maybe it is. How do you know?
I
Do you
think
have a
that
better solution in mind?
I don't have in mind, but I'm trying to figure it out how it can be. So maybe in this to optimize the time complexity, we can use some kind of combination of heap and a hash set and hash map.
Yeah, and heap is just a priority queue for, I don't know.
Yeah,
If
keep.
anyone is more familiar with that terminology, yeah.
Yeah, but what the problem I see there that we in the hash map we have a key and a value, but in the priority queue or heap, how it can be called, we have only a value. So
technically true, yes.
So maybe we can use some kind of additional IDs. So for example, we create some kind of priority queue. And it will store the scores. So it stores in ascending order. Yeah. Okay. And
Descending. What does it mean to?
Oh yeah, I clarify this what I mean.
Like usually you define priority queue in terms of, do you want top to be minimum or maximum?
Okay, let's write it in another way. Let's use so the top is max.
Yes,
So it's a maximum value. Yeah. Max heap.
Makes sense.
But what I see the problem there that we store only the scores, and the scores cannot be identifiers because it can happen the situation that there are two or more the same scores. So how we can
I mean, you said we can't store boss. Why is that?
what can you repeat, please?
Yeah, you said that we cannot store boss this score in the player ID at the same time.
Yeah. That's what I'm.
Okay, okay, you're going to address it.
That's what I'm going to tell the next. So in the priority queue, as a value, we can use not only the score but also an ID of the player. Okay.
That's an option.
So we can store a pair of score and player ID. Okay. What's the problem I see with that? If we have to increase the player's score, we have to iterate over the priority queue and find this one to increment it.
Do we really?
I don't. I think yes. No. Maybe I'm not understanding something.
Yeah, sure. So you see, this situation reminds me of. I don't know if you will find the analogy useful, but it reminds me a lot about Dijkstra algorithm with a heap. Right? We want to update the distance, sort of. And as far as I remember, there is a way to do it without removing this entry from the queue. But instead you will ignore it later when top K comes in. Yeah, so it's also a bit of a distant connection, so feel free to ignore it if it does not make sense now. maybe you have a better idea that it's possible.
So now we are talking about how to change the score of the player in the priority queue without iterating over it.
Yeah,
I'm right?
Yeah.
Okay. So you said that we can use something like a lazy update.
Essentially, yes. Like we would just ignore the old pair. Is that possible? Is it maybe not possible?
It sounds like for me, we can create for lazy updating. We can create a hash map that will store the player ID and its score.
Well, we planned on having this hash map anyways, all right? So yeah, we can have it, and it essentially tells us what is the most recent score of a given player.
Yeah. And for example, let's take a situation when we have to get the top of 3 players, and one of the players in this top 3 has an updated score in the hash map, but it has an old value in the priority queue. So what we can do, we can check if this player has an updated score in the hash map and retrieve it from the priority queue and add it again. It looks for me. I have to understand the time complexity of this operation. So return from the retrieve element from the priority queue takes time of log n. If I'm not.
No, that's right.
Yeah, that's right. Yeah. And so it's removed. And add element to the priority queue also takes log n time.
That's right.
Okay, so what it helps us. So if we have to return, return the sum of the top k players, with this technique using a lazy initialization, we reduce our time complexity from O of n. So when we have to check all the elements in the priority queue,
I believe it was of n log n because we have to sort.
Yeah, you're right. Yeah, from this time complexity, we reduce it to so we reduce it to, I think, k.
Well, we would need to use k operations, right? Because we want to access top k elements.
Yeah, k elements, k log n. Yeah, right. So we reduce the time complexity. So it's better one. So
I have a question. Is k operations the worst case?
K operations. It's
because we sometimes, if you remember, we sometimes have an old value in our heap that we have not yet removed, right? It's possible that they pile up. So is this the worst case complexity, or perhaps some other kind of complexity?
Okay, so you told that I'm not included the complexity of removing and adding elements.
No. So this refers to, I believe, like these operations, they come up in 2 cases. First of all, when you add score, you do remove, you do add. That is fine. Or actually, when you add score, you don't do remove, right? You just do add. Is it correct? Do I understand you right? here we only add, right?
Yes.
When we reset, we don't do anything with the heap, we just update the hash map, right?
Yes. Yep.
But when we use top k, the heap may contain alt pairs, right? With score not being equal to the value of this hash map for the corresponding player ID. We have to remove them from the heap and essentially ignore them, right? Not put them back or anything like that. And whenever we encounter a valid pair, like where the score is the most recent, right? As far as I understand, we like temporarily put it aside and then we will put it back.
Yes.
And that is where of k times logn comes from. But we have not accounted for these alt pairs. Right? Their number is not necessarily limited by k.
So you mean the alt pairs? I understood you. So if we have alt pairs in our priority queue,
and they are among the top k, then we will need to make more than k operations.
Okay, and in this case, we have to retrieve more elements. So it's not possible, I think, to figure out the top bound of it.
Well, like surely not more than n.
yeah. We can we can use something like m there and say that m is always less than m. Maybe it's equal. We have to figure. Yeah. Let
is
equal.
big of right. Right, but yeah, so this is the worst case analysis. It is correct. Potentially, we'll have to use entire queue. I don't know. Your previous analysis with k here was also correct, but that is not worst case analysis. Do you know of any other kind of complexity analysis?
Actually, no.
Okay, so just to give, I will intervene here. Usually I would do this remark at the end of the conversation, but for anyone wondering, this is correct if you say that this is amortized. Meaning that if you perform many such operations, if like every old element can be removed only once, so it cannot influence many consequent operations with the same k or stuff like that. This is actually common in some in certain library structures. For example, adding an element to a variable size array, like a vector, or I don't know what you have in. Do you code in Java by chance?
Yeah, in Java. Yeah.
Okay. What do you have for like an array list?
Array list, like so a dynamic array.
I believe appending an element is of one, right?
Yep.
But only amortized, because sometimes the array has to reallocate, and that takes longer time. So this is the same kind of amortized complexity. But just to make you feel more confident about it, that was correct if you just say that it's amortized.
Okay.
Yep. Great. So that makes sense to me. Would you like to implement this solution now, or maybe like just go once again over it to make sure that we know all the details?
Okay, let's go again about all the stuff, and then I can implement it. So the first function add score, what it would do? It will use the hash map to add element if it's not in the hash map, or update the value if it's already in the hash map. Reset function. So it will reset the score of the player. So it will find the element in the hash map and set its score equal to 0. And top k, by the way, when we add score in this function, and this element is not already in the hash map, we have to put it to the priority queue, only if it's not in the hash map. If it's already in the hash map, we will use lazy initialization. Okay. And
I believe. Okay. Go ahead.
Mm-hmm. And top function that we discussed will retrieve top k elements from the priority queue, and it will check if the value of the score have been updated in the hash map. If it is updated, it will remove element from the priority queue, update its value, so like change the value, the previous value to a new one, and add it again to the priority queue. And it will guarantee that we will retrieve top k players, so with the maximum value.
I'm a little bit confused. Yes. Are you sure that that is how we want to do lazy updates? Because I feel like if we updated them in top k, right? It may so happen that we wanted to update. We called add score for several players with a given score, right? Then there is k plus first player. They currently have a small score, but there is a pending update that would put them into top k, but we will just not consider them if we do it this way.
Yeah, that's a problem.
Our previous plan was to always insert updated value in the heap, and then ignore whatever old values we pull out. So we perform insertions straight away, but we make lazy removals. I believe that was the plan when we discussed it previously.
Yeah, I think
if I'm wrong.
Yeah, I was. It was my I was confused. So, I didn't understand your approach, and my approach was a little bit incorrect. So, if I correctly understood you, we will add always values to the priority queue, even if they already exist in it. And when we retrieve elements from it, we will check if the elements among the top k are updated in the hash map.
Yep, that makes sense.
Okay, so I think it's time to code it.
Sure. Should I can give you a boilerplate code for this problem if I can look it up quickly.
Yeah, please.
On the leaderboard in Java, right? Java. Java or Java? Okay. If you don't mind, I will put it on the next page.
Okay, it's much better.
I have a constructor just in case you need it.
So as we discussed, we will use a hash map, and a key of the map will be the play ID. I think it's integer, and the value is also integer that represents the score.
Oh yeah, you inferred it from this type.
Yeah.
Okay.
Then let's create a variable of priority queue. It will use an array of, so we'll represent pairs as an array because Java.
Lazy. Okay.
Yeah. I'm lazy. I don't.
I mean, a pair class is not
I
difficult to
don't.
define, but I can understand
Maybe
your
we
unwillingness to do so. No, that is a big
actually
problem without it.
we can define a class of pair. It's better to understand. So
Because you can name fields. You could name them, player ID and score if you wanted
yeah.
to.
Oh yeah, it's a good idea.
Wrong. I don't know what language is that, but
Yeah, it's play score and I score an idea. So it's a constructor.
I think in Java there is a record. It
Yeah,
lets you do the
it's.
same thing simpler.
I don't know if lead code understands the record type. Because it's the new type and was introduced in the latest version.
Are you sure about that?
I think
I think
yes,
it's
in
from
the
like Java
Java's
14 even. There is
yeah.
record.
I think it was
like LeetCode uses Java 17.
okay, so it can be written with record, but I already written a constructor, so
Okay. Oh, actually, LeetCode even supports like a pair class straight away.
Yeah,
but it's
oh,
like from Oracle, so the syntax maybe not as clear as ours. Anyways, we have a good thing going.
Okay, we can use a record. It's a simple one. So in this case, let's define score and player ID in the braces. Okay, and okay, so it's done.
Is it? Yeah. Just grab it to check if it's.
Okay, let's initialize the map. And we have to pass as a comparator as a parameter of priority queue to compare pairs by the score value.
Oh, so we're both. Oh. Dear moment.
Okay.
Or can you not name types? Cool.
Yeah, it's possible.
Okay. Oh, I guess map knows its value types, so.
I actually think it should work, but
No, fine. We will check it.
We'll check it later. Yeah. So let's move to the implementation. So at score, first of all, we put the map values, key and value, but we have to check if it is already in the map. We use a method contains key to check if it's already in the map. Yep. So in this case, we put a new value. but we have to retrieve the old one.
Oh wow. Is
And
there? Yeah. Sure.
I think there
Is
is
there like a square brackets operator for element access? No.
no. We can
Wow.
use a merge function if I'm not mistaken. So we can
Well, let's keep it simple because I'm getting a
yeah
little
yeah
bit
yeah.
overwhelmed with Java here.
In Python it looks easy, much easy because we can use our syntaxes without this function defined in the classes.
No,
Otherwise,
contains is a reasonable thing. We have this in C++, and many people use it, in C++ 20 at least. Yeah, but yet calling get every time is a little bit inconvenient.
okay, so it's a little bit confusing formatting, but I'm trying to do it better.
Sure.
After that, after we have put an element to the hash map, we have to put it to the priority queue. We'll use construct a new pair class. So scar value, and yeah, by the way, we have to get from the updated scar. We have to get from the hash map.
Oh yeah, that is, this score is just the delta that we increment by. That's right.
And the play ID, we have to pass it. Okay, that's all for the add score method. Let's move to the reset one. So
yeah, that one's easy.
yeah, that's for the most easy one. Simply we have to update the value of the play ID. So simply put it 0.
Yeah, that will work.
By the way, I have a question. If we have to check if the map, so our leaderboard, contains this element, like a player ID.
No, it's guaranteed to contain this player ID.
Okay, that's fine. So, and the most complicated function in this class is stop. So let me remind what we have to do. We have to okay, we have to iterate 8 times.
Okay.
And at each step, at each iteration, we retrieve element from the priority queue. Yeah, it's type not integer, it's a pair. And this is PQ. This is PQ all, I think. Yeah, but it retrieves an element.
Okay.
Okay, so let's define a variable sum and initialize with the 0. After we pull the element from the priority queue, we have to check its value in the map. So let's name it scoring map and use a get method from the hash map. So now we see if this.
Okay, yeah.
Yeah.
I think it was just a player. No, it was player ID. I remember at some point it was just player, but no, it's player.
Maybe I changed the value. Yeah.
No,
so this score in map is an updated value. And in this case, if top So if we already pulled the element from the hash from the priority queue, and we will not put it back if the values are not equal.
Correct.
But if the values are equal, what we have to do? I think we have to create another collection there to store both elements. I'm right?
Sure. You can have like a array list or whatever you want.
Yeah.
Or even a list.
Both elements, both pairs. Let's name it like this. Okay. If so, on this step, we check if the top score is not equal to the scoring map. Actually, we have to change it to the equal. So if the scores are equal, we put the element to the both pairs collection, and it means that it will be returned back to the priority queue.
They have top.
Yeah, and the last thing we have to do there is to update the sum variable. So
what are you trying to do?
Yeah, I'm trying to update the sum variable,
but sure. But when does it happen?
Yeah, I'm thinking about it.
Okay.
If the score in map are not the same, so let's define an else array, else case there. Actually, we don't have to put it again. Yeah. Okay, let's remove an else break brackets branch. Yeah, thank you. And easy update sum. Yeah, sync like this one. But maybe not in there, maybe in this branch.
Yeah, that makes sense.
Yeah, update sum in the, so if we yes, yeah, I understood. If we add an element to the pulled collection, it means that we take this element into consideration. So we just don't skip this element, and in this case we update the sum variable.
Yep, that makes sense.
Okay, and now maybe we haven't retrieved all the key elements because some items from the priority queue we skipped.
That's possible.
So if we skipped, so in the else branch, I will define a case when we skipped the element. So in this case, I just decrement the I. It will make loop to iterate one more time.
That's an interesting way to fix this. I think it will work. But that is surely not what I expected. No, that's cool. That is a cool way to do it.
Yep. So
although it would not work in languages like Python, because it doesn't matter. Keep going.
I think in Java it should work.
No, in Java and C++ most probably yes. In Python, well, depends on. Yeah.
Okay, and the last operation we have to do is to put all the elements back to the priority queue. I will use method at all.
Oh, that's convenient.
Yeah, that's convenient. I
think
think
we
it should.
have range-based functions in C++ too. I'm not so sure about Python. I think Python actually.
Okay.
convenient.
So, and the last step of this function is to return the result.
Okay. Okay.
Well,
Are you happy
I
with this code? Would you like to run it on some examples?
yeah. Let's run it.
Do you want me to provide an example or...
Yeah. You could provide the basic example from the lead code.
So first of all, it does not compile.
Maybe it's
At least 3.
the problem with the styling of the Google documents. Maybe.
Do you mean formatting? No, there are other issues with the problem. Okay, let me help you out as to not waste time. So first of all, here you have an extra closing bracket or bracket.
Yeah.
Secondly, here, because we are using a custom pair, it does not need to be a template.
Yeah.
And
That was my
thirdly,
problem.
here you have player ID, not a, yeah. Now it does compile. I'll give you an example. I do not make it short. Okay, yeah. On the next page, here is an example for you of expected input and output. So that represents the method call, right? And that represents arguments. Of course, so we construct leaderboard with no arguments, and we add score of first player, set it to 73, add score of second player, set it to 56, third player, fourth player, fifth player. Yeah, and here we call top 1, right? So among all these players, that's obviously 73. Then we call reset of first, reset of second. So these are no longer in the queue. And we add second back with a score of 51. So now these 3 are valid scores, and their sum of 3 is what? 51 plus 51 plus 39. That appears to be equal 141.
Okay.
One more question I have for you is, remember how we said that by default, we want a max heap, right? What is it in Java by default?
Yeah, it's a problem there. So I think we have to change the comparison there like this.
Can you also put a negation sign here? Does that do the same thing?
I think it should do the same.
Okay.
So
no, let's do it any way you want.
Okay, let's do it with changing the parameters order.
Yep. All right. Okay. Okay. Yes, we can walk through this example.
Okay, let's start with the add score. I will create the map, something like a map. Comment for debugging purposes. So let's add.
Do you write it? Oh yeah.
Okay, yeah. I wrote this. I wrote the comments. So add. So in the add score function, what we will have, we see that this key is not in the hash map. So we just put a new element to the hash map. will contain player 1 and the value of its 73. And to the priority queue, we add a pair of 1 and 73. Let's
could you please write them in like, well, score comes first, right? So it's like
what do you mean by
73,
this?
I mean, in the pair, score kind of comes first.
Okay. I understood.
I don't know. Maybe that will be like visual, like more.
The next element is 256. So, like with this one, we put 2 and 56. And the next element will be 56 too. So we don't change the order in the priority queue. The following one, so add score is 339. Let's put it to the hash map. And in the priority queue, we also don't change the order. The next one is 451. We put it to the hash map, but in this case, we put the element into the priority queue. It's not the last element now. So we put it there, and it will be 51. Okay, the next operation is to, we also have a 54 to add. Okay, and it will be the last element.
Yeah. Well, technically, priority queue does not store them sorted, but like, I suppose it's just for the visualization purposes. Right?
Yep. So now let's use a top function with parameter of 1. It should return 73. Let's go to the top. We have a cycle. We put the top value. The scoring map is the same. So we go to the if branch when the value of top score and scoring map are equal. We added the element to the pool pairs, updated the sum variable. Now sum is equal to 73. Okay, and we end up with this cycle, added all elements to the priority queue again. So we returned back element with value of 73 and returned sum of 73. So it works. Now let's move to the reset function. We reset the first element and reset the second element. Now what we have in the hash map, we have like this and this. We don't update the priority queue because, as we mentioned, we have a lazy initialization, lazy updating. Now we add value of 251. Let's go to the add score. We didn't remove the element from the hash map, so it contains, but its value is 0, so we just add the score value of 51 to the 0, and it's 51. So in the hash map, we have 251. In the priority queue, we just add a new pair with value of 51 and 2. I will put it to the back of the priority queue.
Sure.
Okay, and so now let's check the top of 3 elements. Let's start with the first top element. Is this element 73, and it's nothing changed with it. So just put the 73, update the sum value. Sum value now is 73. Okay, the next element is interesting. It's 56. The play ID is 2. And we see that scoring map now is 51, and it's not the same as 56. In this case, we decrement the I variable to iterate one more time, and we don't put this alt pair with the player ID of 2 to the pooled pairs collection. So we just skip this element and remove it from the priority queue. The next one is 51.4, and with this element is all right. This element is right. Its value we increment to the sum. So plus 51. Now we move forward to the element 51.2, so the element that we added the last time. We see that is the updated version of the player 2, and its map value is the same. So we update the sum again and add 51 there. Okay, we end up with the fourth cycle, and the last thing we have to do to add all these elements to the priority queue again and return the sum. The sum of this will be 102 plus 73 is 100 and... Oh. Something wrong there, Kita. Because this value is not the same.
Wait, hold on. You said 51 plus what? Once again?
51 plus 51 plus 73. Maybe I...
Wait, no, we reset 73 at some point, I believe. Like here we reset 73, right? We reset 1 and 2.
Yeah, it was my trouble. I reset it in the map, but I added it to the sum.
Okay.
So let's update it, this version. We remove 73 and we add 51, and the last element is 39. Okay. Oh, yeah. Now it's 141. So it works.
Cool. Okay. Sure. We'll stop here for now. Yeah, because we have like an upper time limit.
Yeah.
If you don't mind. Okay. And we will walk over the feedback, probably, right?
Okay.
All right. So let me share it this way. I have a feedback form. I think we can do this in Ukrainian, actually. What do you think?
Yeah. Так, давай.
Давай. Цей мок – частина довшої серії моків, яку ми організовуємо в спільноті. У нас є формочка для фідбеку, там ви проставляєте якісь сигнали, які ви побачили або не побачили на інтерв'ю. Як тебе підписати?
Можеш так залишити?
Добре. Не будемо розголошувати особисті дані. Починається насправді форма з того, що ми задаємо clarification. Єгор про це забув, на жаль. Так, а тут насправді багато clarification'ів, які можна задати. Наприклад,
так.
До того моменту, як я вставив інтерфейс, було незрозуміло, що таке player ID. Player ID міг бути, наприклад, string. Так, це мало впливає на цю реалізацію, так, але, можливо, на якусь реалізацію впливало. Може, хтось замість хешмепа використав би array, якщо player ID, скажімо, маленьке.
Так.
І можна було використовувати таку індексацію пряму. По-друге, і це більш важливо, ти не спитав, що робити, якщо в топ K більше, ніж розмір мапи.
Так,
У нас
я
просто
вважав.
більше гравців, ніж треба.
Так, я вважав, що воно буде все підходящим, так?
Так,
Але
воно не
треба було
буде,
спитати.
воно не буде перевищувати, не треба це окремо обробляти, але краще про це запитати.
Угу.
Наступне питання також не впливає на розвиток задачі. Хоча як, трішки впливає. Так? Чи можуть скори бути від'ємними?
Угу.
Тобто, якщо це там якась гра на гроші, так, опускаємо легальність цього питання, то хтось може отримати негативний скор. Це буде позначати якийсь такий програш. І це важливо в тому моменті, коли ми додаємо ще 0 в мапу. Тоді є семантична різниця між видаленням ключа з мапи і зміною значення на 0. Бо 0 може тоді опинитися в топ-K, в той час, як ми очікували б якесь від'ємне значення там побачити. Ну, в принципі, тут також можна було запитати про семантику ресета. Це типу ми виставляємо скор в 0 чи видаляємо гравця повністю. Оскільки я сформулював питання так, що ми виставляємо його в 0, то, в принципі, оці мінуси не вплинули б на результат, так, тому що я сказав, що 0 треба розглядати. Але про це можна було запитати. Ну і інше питання, чи можуть скори оверфлоунутися? Зокрема, це важливо, було б дивно, якби вони могли окремих гравців оверфлоунутися, так, тоді тобі ніхто не давав би тут тип int. Але вони можуть оверфлоунутися в сумі, тому що тут ми додаємо потенційно k це потенційно велике число різних інтів.
Так.
В нашій задачі, не подумайте, нічого не оверфлоується, тому тут багів немає. Оцей розвиток, як є, він проходить тести на літкоді. Це важливий момент. Насправді тут є баг дуже нетривіальний. Я вже завів баг-репорт літкоду, тобто в них слабкі тести на цю задачу. Якщо якась компанія взяла б цю задачу вам на інтерв'ю з літкода і запускала б на тестах літкода, то тут ви б проскочили. Так? Нетривіальний момент який? Ми ось тут порівнюємо зі score in map. Так? Топ-скор порівнюємо зі score in map. Правильно?
Так.
І вважаємо, що якщо воно рівне, то це актуальний скор. Це не зовсім так. Може таке бути, що людина спочатку набирає 100 балів, потім її скор ресетиться, і вона знову набирає 100 балів.
Ага.
Тоді в Q потрапляють дві пари, ми обидві будемо сприймати як валідні. В той час, як тільки одна з них актуальна.
Так, а це слушне зауваження, так.
На літкоді таких тестів немає.
Його нема.
Я про це не знав. Так, я вже завів на GitHub і їм кажу, що додайте такий кейс. Можу вставлю в посилання під відео, якщо відео буде, на цей баг-репорт. Це дійсно щось нетривіальне, я думаю, багато інтерв'юерів цього б не помітили. В Гуглі, напевне, помітили, не знаю. Але це щось складне. Я трішки відволікся від фідбеку. Тобто по комунікації все добре, але clarifying questions не вистачає, тому тільки 3. Так, але зрештою трейд-офи, організація і комунікація під час набору коду, все було нормально. Тепер питання про клари, воно є і в problem-solving секції. Так, Єгор придумав оптимізований розвиток з хіпою, трішки завтикав на time complexity. І тут я також це поставив, я не знаю, як це правильно сприймати. І дійсно, ми почали з якогось наївного розвитку, це завжди добре. Це вам цементує якийсь мінімальний трешхолд, від якого можна потім відштовхуватися. І часто на практиці якісь оптимізації вони не спрацьовують, тому що у вас розмір вхідних даних, наприклад, маленький, і робити щось занадто розумний, немає сенсу. А так у вас є вже такий бенчмарк. Ну, follow-up problems extensions тут насправді не було, але це і не впливає на скор. Тепер technical competence у нас є такі. Coding style, я не знаю, це часткова проблема з Google Доками, що тут все так поїхало.
Так.
Але,
Проблема доків.
Ну, я зрештою і не вплинула це на скор, так, тому що є різні підходи з рекордом, з власним класом, багів, ну, як. Був баг невеличкий з компаратором, що за замовчуванням це min-хіпа, були якісь описки в цій функції, а так нічого такого. Ну, крім того, нетривіального багу, який ми вже проговорили. Це, типу, баг розв'язка, а не кода. Тому по коду мені все сподобалося. Особливо i-. Я б тут, наприклад, написав while pulled pair size менше k.
Ну, як варіант, так.
В Python таке не працює, тому що в Python for loop, він, наприклад, range-based. Якби тут був якийсь range-based for, то наступний елемент він завжди підтягувався з range об'єкта, або там з колекції якоїсь, по якій ми ітеруємося. І оця зміна насправді не мала б ефекту на наступну ітерацію. Тому мене це трішки, ну, я не очікував такого, але це прикольно.
Дякую.
По дебагу про тести, так? Часто, якщо вам не дають тести одразу, то це не означає, що інтерв'юера їх немає, це означає, що він забув це зробити. Я, наприклад, забув дати тобі тест якийсь спочатку. Це частково мій провтик, але в таких випадках треба, ну, по-перше, запитати, а по-друге, якщо тобі кажуть, ой, не знаю, це складно, то можна якийсь свій тест придумати.
Тобто, ти маєш на увазі прямо перед тим, як кодити щось, питати тест.
Перед тим, як розв'язувати задачу, попросити, ну, це допомагає попросити інтер'єра пройтися по тесту якомусь маленькому, це допомагає зрозуміти, чи дійсно я правильно
розв'язую. Я зрозумів. Так.
Я тут багато тицюю, що корнер кейси. Ну, ми знайшли, зрештою, ось цей баг, тому я не проти.
Так.
Але головне в цьому дебагу, так, це тестування, це systematic manner. Так, тобто те, що зробив Єгор, це дуже класно. Він виписав тут список, що, куди, так, в такому цікавому форматі. Я не думаю, що це можна вставити в Java як ініціалізатор чогось.
Ні, не можна, на жаль.
Не можна. Ну, і в Python, коли я розв'язую задачки, я намагаюся, типу, дотримуватися конвенції, що в мене виписано те, що якщо його вставити в інтерпретатор, то це буде той самий об'єкт. Можливо, в Java це складно, але в Python я, наприклад, міг би сказати, що це там 1, 0, 2, 51 і так далі. В C++ також є нотація, що мапа – це списочок пар, тому пишете пари і фігурні дужки, щоб позначити мапу. Якщо таке вставити, то це валідний об'єкт. Але цього, ну, типу, це також нормально візуально. Тому головне, що людина бачить, що відбувається, інтерв'єр бачить, що відбувається в коді, розуміє, що не так. Я трішки відволікся тут, коли ми там 73 заплуталися, тому що я заповнював цей баг-репорт, шукав кейс, коли щось не працює. Але в цілому мені сподобався. Тобто, я, наприклад, не передбачив такого варіанту, тому я не буду знижувати за це оцінку.
Зато знайшов баг, це теж добре.
Так. Що ще? Давай я з тобою зашерю цей документик, у мене там є ще інша задача. От, це коли я готуюся до моку, то в мене є такий от документ. Там все, що я знаю про задачу, це якийсь informal statement, без всяких подробиць, якісь клари, які я очікую, що в мене можуть запитати, і як на них відповідати. І декілька розв'язків. Ось тут є ще розв'язок з partial sorting. Detail. Сенс там який? Що оці скори, насправді нам не обов'язково їх повністю сортувати. Нам достатньо знайти К найбільших. Ну, це типовий use case для Quick Select.
Треба, до речі, прочитати про Quick Select.
Ну, типу, в C++ функція anti-element розбиває range на 2, таким чином, що всі елементи звідси спочатку до середини менше рівні середини, а з середини до кінця більше рівні середини. Але не факт, що всередині цих блоків вони впорядковані. Тобто, по суті, що вона робить? Вона знаходить катий елемент, катову порядкову статистику і робить партішн. Всі, хто менше в одну сторону, всі, хто більше в іншу. Прикол цієї штуки в тому, що вона працює не за O від n log n, а за O від n. Тобто ще один спосіб заощадити в цій задачі полягає в тому, що ми часткове сортування робимо. Не повне, а часткове. Тут в мене написано O від K, це трішки специфіка мого розв'язку, і C++. Там можна зробити за O від K, просто можемо подивитися на цю посилку також, якщо ти хочеш.
Давай.
Фішка в тому, якщо використовувати якийсь tree map, впорядкований map, або tree set з цими скорами, так, то в C++, наприклад, інкрементування ітераторів по цьому сету, воно працює за O від одиниці, принаймні амортизовано. Відповідно, ти нічого фізично не витягуєш і не вставляєш назад. Але зрозуміло, що у мультисета константа суттєво гірша, ніж у Priority Queue, тому тут якби без бенчмарок нікуди не підеш. Я не виділяв Priority Queue в окрему тему, де просто сказав, що з різними структурами даних можна досягнути O від log n, O від K, O від log n. Або
В Java нема мультисету, на жаль. Скільки я розумію.
Ну, можна set par завести. Це я просто в тому плані, щоб не сторити player ID, тому що я явно ерейжу score з скорів. Ну так це. Тобто у нас було насправді трейд-офф такий, який ми не розглянули, це що з Priority Queue краща константа, але не можна ерейзити, з tree мапи або tree сета гірша константа, але можна ерейзити по player ID. Але так чи інакше, головне, що ми досягнули асимптотики log, k, log. Це було основне в цій задачі, як я думаю. Тут super advanced follow-up, я не буду його розглядати, якщо ти не проти.
Я думаю, що він дуже advanced.
Так, а ще така фішка, що якщо k, наприклад, велике, то k log n не обов'язково швидше, ніж O від n. Так, тобто, в залежності від співвідношення цих вхідних даних, часткове сортування може вийтися швидше. Якщо, скажімо, у тебе 1000 елементів, а ти хочеш топ 500. Тоді лог 1000 він навіть 10, але 500 на 10 це все одно 5000 операцій, а тут їх всього 1000. Ну, насправді, в часткового сортування такого також не дуже класна константа, але тому не очевидно, хто з нею був би кращим. Так, але сам факт того, що не завжди k log n краще, ніж O від n, це нетривіально. Добре, на цьому в мене фідбек, в принципі, все. Задача непроста. На дизайн класу Єгор з нею впорався доволі добре, як я вважаю. Можливо, в когось ще буде в коментарях якийсь фідбек для Єгора. Давайте, або похваліть.
Буду радий. За старання і намагання.
Добре, я тоді зупиняю запис. От, що там. Бажаю вам гарного дня і до зустрічі завтра, або коли ми там побачимося з вами.
Всім пока.